Hello students, good morning. Today we are going to start exercise 2.3, and before the exercise we have some theorems to related the exercise 2.3. So at first we will understand carefully the theorems of exercise 2.3. So the first theorem is 2.4, and the theorem is prove that square root of 2 is an irrational number. Okay, theorem 2.4 is prove that square root 2 is an irrational number. Okay, so let's square root 2 is rational number, then we can write in the form of square root 2 equal a upon b, and we can also write in the form of a equal b square root of 2. Okay, squaring both sides, then we get both side, then we get a square equal 2b square. Put the equation first. Okay, in equation first, if 2b square is divisible by a square, then two b is also divisible by a okay, then we can say a is divisible by third number, divisible by any third integer, c. So a equal 2c. Put the equation number second. From equation first and second, then we get 2c square equal 2b square, and value of b square equal 4c square upon 2, and we get 2c square. So the equation is b square equal 2c square. Put the equation number third. From equation first and third, our imagination were wrong, then we can say square root 2 is an irrational number. Hence proved. For theorem 2.5 and 2.6, we can put the value at the place of 2 x, then let x equal 2, 3, 5, 7 and any prime numbers. So put the value of x at the place of 2 x okay. For the theorem of 2.5, we put the value of x equal 3. For theorem 2.6, we put the value x equal 5. Okay. Let's restart the exercise 2.3, and the first question is prove that 5 minus square root of 3 is an irrational number. Then let's 5 minus square root of 3 is rational number. Then 5 minus and root 3 equal a upon b, and we get the value and root 3 equal 5 minus a upon b, and we can write in the form of and root 3 equal 5b minus a upon b. So from theorem 2.5, square root 3 is an irrational number. Then 5 minus square root of 3 is also an irrational number. So our imagination were wrong. Hence proved. Our next question is second. Prove that the following numbers are irrational numbers, and the first is 1 upon square root of 2. One upon square root of 2. Let's 1 upon square root of 2 is rational number, then we write in the form of 1 upon square root of 2 equal a upon b, and b equal a square root of 2. Okay, both side squaring, both sides, then we get b square equal to a square. Put the equation first. So in equation first, in the above equation first, if 2a square divisible by b square, then 2a is also divisible by b, so we can say b is divisible by any third integer c, then b equal to c. Put the equation second. From equation first or second, so we get 2c whole square equal to a square, and we get the value of a square equal 4c square upon 2, then we get 2c square. So we can write the step a square equal to c square. Put the equation number third. From the results of equation 1 or 3, our imagination were wrong, then 1 upon square root 2 is an irrational number. Hence proved. Next, both parts of equation 2 are same. Let's see equation number 3. If p and q are positive prime numbers, then prove that square root of p plus square root q is an irrational number. Square root p plus square root q. Okay, square root p plus square root q. Let's root p plus root q is rational number, then we can write in the form of root p plus root q equal a upon b. Okay, we have two integers p or q. we get the value of one integer in both. So catch the first integer p, then we find a upon b minus root q, both side square, then root p square equal a upon b minus root q square. So we get p equal a square upon b square minus q plus q minus 2a upon b into root q. Then we can write in the form minus p plus a square upon b square minus q equal 2a root q upon b. Okay, take the LCM of LHS side is b square, then we find a square minus pb square minus qb square equal 2a root q upon b. And we can also write in the form of, the next step will be square root of q equal b into a square minus pb square minus qb square upon 2a into b square, and the b is cancelled by square, so we get a square root of q equal a square minus pb square minus qb square upon 2ab. Okay, from theorem 2.4, square root q is an irrational number then root q plus root p is also an irrational number. So our imagination were wrong, hence proved. Okay, today's class is over.